Hi everyone, so today we're going to be talking about adding and subtracting in the factorial base system. So first I'll just start by explaining what the factorial base system is, so that once we get into addition and subtraction it makes a little more sense. So how it works is each place value is going to increase by a number with the factorial. So for example, your first place value is going to be 1 factorial, then it's going to go up to 2 factorial, the next place value will be 3 factorial, 4 factorial, and so on, and this could go on forever. So I've just done the first 5 factorials because that's what we'll be working with in our problem. And each place value, you're only going to be able to use the digits from 0 to that factorial number. So for example, if we're working in the 5 factorial place value column, we will only be able to use the digits 0 through 5. And the reason we do that will make a little more sense as we go on through the problems. And another important thing to consider is how much each of these place values are worth. So for example, our 3 factorial is going to be worth 6 because the worth can be determined by doing the number times the number minus 1 times the number minus 2 and so on until you reach 1. So for factorial 3, we did 3 times 2 times 1, and that gave us a value of 6. And that's why our worth for this, or the value of this 3 factorial place, is going to be 6. So now let's look at our addition and subtraction problems. So first we'll start with 33,211 plus 4,301. So just like normal addition, we're going to start with the farthest column on the right. So we have 1 plus 1, and right away that gives us 2. And since we learned that we can only have digits 0 through 1 in the 1 factorial place, we're going to have to carry over to the next column, just like in base 10 addition. So if we regroup these two singles, we're going to create a group of 2. And we know that that can be carried over as 1 into our 2 factorial column, and then we'll have 0 left over. And the reason we know that we can carry this over into our 2 factorial column as 1 rod of 2 is because all of our numbers in 2 factorial are worth 2 singles. So just like in base 10, this column is very similar. The first factorial is very similar to singles. And then we're going to make rods of 2. But what's different is we don't really have flats or cubes or anything like that. It's just going to be what we regroup into, or the groups that we create when we regroup are going to increase by the factorial. So if we were going from the 2nd factorial place value to 3 factorial, we would regroup into groups of 6. So next, if we look at the 2 factorial place, we have 1 plus 1, that gives us 2, and that works because we are in the 2 factorial. We don't need to regroup, we don't have any left over, or any extra that we need to carry. So then we move to 3 factorial, and we have 2 plus 3, and that gives us 5. And we'll write this below here because we know that we can only have 0 through 3 in the 3 factorial column. So what we're going to do is we're going to look at the next place value next door, and that's going to be our 4 factorial. So what we can do is we can regroup 5 of these singles. If we look at just this column, we can consider them singles. We have 5 of them, so because we're working in the 4 factorial next door, we want to take 4 of the singles, and we know that those can be regrouped as 1. And then we have this 1 left over, so we'll put a 1 below. And we can cross off this 5. So next we'll move to the 4 factorial column. We have 4 plus 3 gives us 7, plus 1 gives us 8. So again, we'll write that below, because we have 8, and since we're working in 4 factorial, we know we can only have 0 through 4. So now what we're going to do is we're going to draw out these 8 singles, And now we have to look to the column next door, and we know that that's 5 factorial. So we're going to regroup 5 of these into one rod of 5, because we're in 5 factorial. And we have these 3 left over, which we're going to place below. Next we'll look at 5 factorial. We have 3 plus 1 gives us 4, and that works because we're working in 5 factorial. So our answer to this problem is 43,120. Now if we go back, we might be a little confused at why we could regroup these, just these 4, when we know that each of these singles is worth, is going to be worth 6 in the 3 factorial. So these are technically rods of 6. And the reason we can do that is because we are going into the next factorial. And if we were to do, since these are rods of 6, we have 5 times 6, which gives us 30. And if we take away 24 from that 30, because we regrouped, if we were to regroup 4 of these, we know that that's 4 times 6, which is 24. And we do 30 minus 24, that gives us 6 left over. So as you can see, we regrouped that 24. 24, if we were to make all of these singles, we would have a total of 30 singles. And then we would take away 24 to make that one rod of 24 in the 4 factorial place. And we're left with 6, which we placed below as the one rod of 6. So that's why it works to just look at the number factorial and subtract that. Like we did here, we took away 4 from the 5 because we knew we were going to the 4 factorial column. But if you want to break it down and look at if we had rods and we broke them down into the singles as groups of 6, we got 30 total singles. We took away the 24 that we regrouped as the one rod of 20, or the one rod in the 4 factorial. We were left with 6, and we know that that is 1 in 3 factorial. So now let's move to our subtraction problem. We're going to do the same exact problem, just with a subtraction sign instead of addition. So we have 33,211 minus 4,301. So again, we'll start with the farthest right column, our 1 factorial place. We have 1 minus 1, that gives us 0. Next we have 1 minus 0, that gives us 1. Both of these work in their factorial base value. And this is a really important thing to do as you go through the steps, is make sure that you're seeing, okay, we can only have 0 through 2 in 2 factorial. Is 1 0 through 2? Yes, it is. So we know that it'll work in this place value. Next we have 2 minus 3 in the 3 factorial column. And just like in base 10 addition, we can't do a smaller number minus a larger number, so we're going to have to borrow from the neighbor. So we're going to make this into 1, 2, and we're going to borrow from the 4 factorial column, so there'll only be 2 rods of 24 left over. So now the way that we can look at this, again, similar to addition, is we're going to consider this worth 4, because it was in the 4 factorial place value. We borrowed 1 rod from the 4 factorial, and we're going to add it to our 3 factorial. So now we have 4 plus 2, and that gives us 6. So we'll do 6 minus 3, and that gives us 3. Now again, we have 2 minus 4, so we're going to need to regroup or borrow again. So we have 12, or 1, 2 here. Take 1 away from the 5 factorial, and since we took this rod from the 5 factorial, we know that 1, 2 in 4 factorial is going to give us 5 plus 2, which equals 7. So then we have 7 minus 4, and that gives us 3. And again, we're checking both of these will work in 3 factorial and 4 factorial. Now we have 2 minus 0, which gives us 2. So our answer is going to be 23,310. Now another thing that I just want to explain quickly is why it works to just consider this worth 5 and not worth the, it's not going to be worth the 120 of the 5 factorial. It's just, we're just going to consider it 5, similar to how we do it in base 10. And the reason this works is because when I borrow, if I have 2 rods of 6 in 3 factorial, so we have 2 groups of 6. And then we want to take away 3 groups of 6. It works to borrow and take away one group of, so we have 2 groups of 6, and we're going to add in 1 group of 24 from the neighbor next door, this column next door. That gives us 1 group of 24 can also be written as 4 groups of 6. So then that gave us a total of 4 plus 2, or 6 groups of 6. So that's why we can just look at it and say 4 plus 2 gives us 6 groups of 6. Same thing here in this column. We had 2 groups of 24 here, 2 groups of 24, and then we borrowed plus 1 group of 120, and that's going to give us 5 groups. 1 group of 120 can be rewrote as 5 groups of 24. So then we add the 5 groups of 24 and the 2 groups of 24, and that gave us a total of 7. And that's why our borrowing from our neighbor works out to just look at the factorial base that we're working with plus the number of rods that we already began with, because we can rewrite them into different numbers of groups with different values. So adding and subtracting in the factorial base system can be really simple once you figure out how to borrow and how to carry in addition and subtraction.